Welcome to homework.
In this problem, we're given the information that glucose makes up 0.10% by mass of blood. And we're asked to find the concentration first in parts per million. That's ppm. And if you want to understand what parts per million is, you have to think of it as if I had 1 million parts of blood, how many parts would correspond to glucose? Okay, so that's what parts per million means. And so if we think about it, 1 million parts of blood, that's 10 to the 6. Okay, this is the total, this is the whole, all the blood. 0.1% of that is blood. So I'm going to change 0.1% to a decimal. Okay, that's the percentage, the fraction of the 1 million that corresponds to glucose. And if I multiply those together, I find that I get 1,000. So this is the whole. This is the fraction that corresponds to glucose. And this is how many parts glucose. So I express this as 1,000 ppm, or 1,000 parts per million. In part B, you're asked to calculate the molality of glucose. Recall that molality is moles of solute divided by kilograms of solvent. Because you need moles of solute, that means you need the molar mass, which so if you look up the formula for glucose and its molar mass, you find that's 180.2. Again, these problems are hard because you're trying to figure out, well, how many, this is a concentration, how do I know how much I have? It doesn't matter. You can have a gram or a kilogram of 10,000 kilograms of blood. All of it's going to contain 0.1% of glucose. So because molality is 1 kilogram of solvent, we're going to say that 1 kilogram of blood contains 0.1% glucose. Again, I chose the kilogram randomly, but I chose a kilogram because it's easy to work with, as you'll see later. So let's say that if I have 1 kilogram, let's do what we did earlier. .001 corresponds to glucose. So of that whole kilogram, a kilogram is 1,000 grams. So I'm actually going to change that to 1,000 grams. So if I have 1,000 grams of blood, I have 1 gram of glucose. How does that help me? Well, if I have the mass of glucose, I can use the molar mass to find the number of moles. So I'm going to take my 1 gram of glucose, and so this is 1 gram of C6H12O6, and divide by the molar mass, 180.2 grams for every 1 mole. And I find that if I have 1 kilogram of blood, that's 1 gram of glucose, that's equal to 0.00555 moles of glucose. So now what I have is number of moles, and if I have number of moles, 0.0555 moles in 1 kilogram of solvent, that's the blood, then my concentration is simply 0.0555 moles for every kilogram, or molal. I'm going to write that in scientific notation. 5.55 times 10 to the negative 3 molal. That's moles for every kilogram. And that's my concentration, that's my molality. Finally, in part C, we're asked not to find the molarity, but to explain what information you need to find molarity. So recall that molarity is moles of solute over liters of solution. We already have the moles of solute, or we saw in part B that we could find the moles of solute. To find liters of solution, what I would need is the density, because I have information about the mass. So I have a lot of information about mass, and to get from mass to volume, what I need is the density of the blood.